Hello friends, the topic of our video presentation is a special type of lens known as the laser plasma lens. But before getting into the details of this device, first let us look at some of the concepts to get a better understanding of the device. Microscope. We all know that microscopes are instruments which are used to obtain a magnified image of the object so that we could have a proper study about the objects which are not visible to the naked eye. The first microscope to be invented was an optical microscope which uses light to image the sample. But due to its limitations, the present day microscopes use electrons instead of light for imaging. These are known as electron microscopes. Such electron microscopes have a higher resolution and thus a higher magnification as compared to the light microscopes. The electron microscope use a beam of high energy particles which are generated by the particle accelerators. But generally these particle accelerators are very large. So instead we use a high power laser pulses and focus them down to the size of about few microns, resulting in a bullet of light. When this bullet of light collides with the glass, it rips apart the electrons from the particles inside and resulting in formation of corresponding ions. Ions, being much heavier, remain in their place and apply a strong restoring force on the drifted away electron. Hence, we end up in a bubble-like structure inside the laser pulse. Inside these bubble-like structures, electric fields are really strong and they are present not only in the direction of propagation of the beam but also in the transverse direction. These electric fields are known as wake fields. As a result, the electrons start oscillating and this phenomena causes problems as it increases the divergence of the electron beam. In order to reduce the divergence of the electron beam and to focus it, we require magnetic field. But such high energy beams would require long distance treatment with the magnetic field. This is where laser plasma lens comes into play. Laser plasma lens. A laser plasma lens is a device which is used to transmit high energy electron beam in a single direction and prevent its divergence. Let us see what is the basic principle behind this. The basic idea of a laser plasma lens is to use these transverse fields to focus the electron beam. It uses two plasma gas jets separated by free space to achieve this. A laser pulse drives a wake field in a first plasma gas jet, diffracts in free space, and drives again a wake field in the second plasma gas jet. As a result, an electron beam is generated and accelerated in the first jet. It then drifts in the free space, where the interaction with the plasma is negligible and is focused by the transverse components of the wake field in the second jet. In general, transverse oscillations in a laser wake field cannot be used to focus an electron beam as the beam electrons oscillate out of phase. But in a laser plasma lens, the required synchronization is achieved by the free drift. Let us look at some of the advantages of the laser plasma lens. First is laser-induced breakdown spectroscopy. It is a novel method of elemental analysis based on a laser-generated plasma. Pulses from a laser are focused using the laser plasma lens to atomize a small amount of the material for its spectroscopy. Second, a polarized light interferometer. This is a device used for high-speed photography of microscopic objects in a laser fusion experiment. It uses the laser plasma lens for focusing the laser-generated particle beams. Lastly, plasma wake field accelerators. These are the devices used to generate high-energy electron beams using the laser plasma lens. It can generate electron beams with the energies ranging from tens of mega electron volts to 1 giga electron volts. Thank you for listening.